Good evening, everyone. This is Shrikar Reddy Edama, and I'm from India.
Hi, this is Ujjwal Mutyala and I'm from India.
Hi, I'm Vance Woods, and I'm right around home here, I guess, Charleston area, or close enough.
My name's Andy Brashear, and I live in Ashmore, Illinois.
So our topic is geographical information system. This looks very simple, but it's a little complicated. So we have tried our best to make it simple and so that everyone would understand it. So to make it easy, we have divided the presentation into different parts. Like I would be talking about introduction, and Andy Brackier would be talking about map creation. Sorry. So potential applications would be dealt by Ujjwal Mutyala, and Vance would conclude with potential problems and solutions. So the basic question comes is, what is GIS? GIS is often imagined to be a simple computer tool to map images, but a GIS is a much more complex technology, beginning with digital representation of landscapes. So how is the data collected? Cameras, digitizers, infrared photographs, and satellite imagery are used to collect the data. Once data is collected, it is stored, checked, manipulated, and enhanced with the use of both software and hardware. So what can be done with GIS? We can map quantities. Usually people map quantities in order to find specific areas which meet their criteria, such as a shopping store may be interested to find the pin codes of the areas which consists of young families and who have relatively high income, so that they can set up the business and concentrate their business in that particular area. In the same way, US public health officials might be interested to find the areas and the number of physicians which are present in those particular areas, so that the service is distributed equally throughout the area. Map densities. GIS, geographical information systems, help to map densities with uniform tools. If you consider the example of population density of counties, we all know that counties are of different sizes and the populations are different. Like one county has more population, the other county has less population, few have like almost equal population. So it's very difficult to differentiate between these populations. So GIS, with its specific and greater ability to differentiate these populations because of the highest accuracy it has got. We can map change. This enables us to predict the future. If you consider a meteorologist, he can predict the change, and then he can predict the future of the course of the hurricanes. So this would enable him to predict like where it's going to occur in the nearby future, and this will enable us to take further plans and protect from the devastating effects of those hurricanes. The benefits of GIT. This is particularly for an organization that can be like better decision making. Here you can consider an example of a real estate site location, and you can also talk about emergency during the time of disasters. GIS helps you to calculate the emergency response time. So this enables you to actually plan better and protect more people and reduce the devastating effects. It provides improved communication. This is possible because of the high quality visualized maps and better record keeping. So mapping, this would be explained by Andy Breck here.
Another important aspect is the mapping of these maps, creating the maps. There are multiple steps in this, which include vision to display the data, got to know what your information is for plotting the points, as well as the coordinate system and map software to display all of your data. For the vision, you need to understand the data you're working with, and there are two types of maps, which include the reference map and the thematic map. Reference maps are like an atlas. You can see features on the map like roads, highways. And thematic maps displays data, with the example of this being the swine flu data. The different types of data you can map include houses, sightings, distances, views, and comparisons. You can also calculate distances using the software. A coordinate system is a generic data that people have collected previously. And then they use the coordinates that you have in this area. So if you find data, it uses the previous coordinates to determine where the location is. Some ways to display the data is one of the most popular is ArcGIS. Whereas it's like an advanced form of Excel where you have the coordinates and you can calculate distances, represent data cleanly. And one of the freeware versions is Google Earth, where people can look around and view different areas of the Earth. And I'll move you on to the uses.
And the uses of GIS mapping. Before going to the GIS mapping, the 3 points were very important. Like I would like to speak about the managed data, analyzed data, and communication. The managed data. This data is collected from the geographical, and by taking the fields of geovisualization and the computer science. The data is properly managed and then is sent to the systems where it is properly analyzed. This type of GIS is used in target marketing segments and planning distribution networks like American company, which is producing electricity and responding to the emergency services like law enforcement and redrawing the government boundaries. And I would like to go with an example of law enforcement. And first I will talk about the resource allocation. The data which is collected from the various sources is properly analyzed. I can show you in this map. Like there are various points where the high crime rate is there. It is designed into various sources. And analyzing the crimes to detect emerging patterns. The required teams has been sent depending upon the crime rate is very high in the appropriate time. And examining the best location to conduct surveillance. Depending upon the more crime rate, the surveillance cameras were used in order to reduce the crime rate in the respective areas. And the last point is establishing a parameter for the crime scene. This is usually used in hostage crisis. Establishing a perimeter so that the only authorized persons can enter. And regarding the natural disaster, like when during the tsunami time, the coastline of the has to be cleared in order to save the lives of many people. And the second usage is the gas utility. The staff of the gas utility, they will regularize in seeing the many parameters like leakages, outrages, and many factors. And the pipeline management provides the best solution for the operation management. The staff is properly maintained, and where the leakage is there, and the required agencies has to be met in order to overcome the problem. And the accuracy of the walls and the regulatory maintenance has to be properly overlaid through the GIS system. Like this, the pipelines has to be properly drawn, and where the leakage is there, they can easily analyze and they can send the response units in the meantime. And the fourth one, the authorization and cathodic protection reports. These reports are used to visualize where the leakage is done in more amount of, so that they can regulate the preventive measures in overcome the disasters. This GIS can be used in further, like incorporating with the CAD, like computer aided design. There we can use we can have a 3D visualization of the models. And regarding the 4D environment, like we can see in movies, in various movies, like the person is exposed to the various like wind and sprinkling of water like this we can see in theaters. And the 5D and 6D and 7D incorporation of touch, like we can have experienced the pressure, temperature, texture, and sound into modeling environment. And limitations and problems.
The biggest limitations and problems are are also kind of the greatest strength of the GIS system. You're taking so much information and you're kind of compounding it, and any error that's in small segments of that information will be compounded or transposed into the larger program. So care has to be kind of taken. Let's see, here we go. And that's where I kind of got these topics. Mapping is only good as the data that you receive. Time-sensitive data is still pretty limited. We just don't have enough information. The information hasn't been out long enough. The data hasn't been available in some topics and some types. Hardline attributes might misrepresent reality. An example of this would be when they're doing mapping on like vegetation. It's difficult to draw a clean line between like swampland and meadows. You might have a transition period in there where it shows only as a line on a map. And that kind of goes along with the relevance of mapping certain attributes in a comparison. The relevance is related to somebody's view of what items will actually correspond with each other, and that's open to interpretation. So you got a little bit a small chance for error there. I go on and it says it's only a tool. Like any technology, it's only as good as how you use it. You obviously don't take a chainsaw to do trim work. So this is the same way. If used in the right way, it's good for a lot of different subject matter. But it can also be twisted or manipulated if used for the wrong intentions. Data can be skewed or biased even. And I went on to say as correlation is not a causation. We kind of went over this earlier. In other words, just because something relates doesn't necessarily mean it's valid with the idea being trying to be processed or posed. No matter how advanced the technology is, there's no guarantee that it's the truth. Just because you see something made with GIS type software or programming doesn't mean it's the absolute truth. It can be manipulated and viewed other ways. And I got one last slide here showing kind of an example here that this shows swine flu cases. And if you'll notice that the biggest clusters are in areas that are of advanced countries that are advanced technologically. So obviously all the data is going to compile in those areas in the North America and European states, whereas other parts of the world, like up in the Soviet district and Northern Asia and stuff, there's obviously probably swine flu there, but the data isn't being reported. So that's kind of a limitation to this type of system. It's only as good as the technology surrounding it. That concludes our presentation. Do we want any questions?
We have time for 3 questions. Yes.
Question number 1, GIS. Any questions?
What occupations did you guys find that used most in? I know I've probably heard of a few, but
Typically global type systems that interpret data from a satellite imagery is what I've found a lot of. But it's more physical aspects than like human-related topics. Not always, but it's easier to predict real things
Right.
like buildings and roads and like pipelines, what he was showing and stuff like that, than it is to try to analyze like human topics that are so dynamic that they're moving around so
Okay.
much that it's hard to track.
Yeah, because I know it's used a lot like in survey work for the Department of Transportation and stuff like that. You use that a lot
Correct.
for that.
But there's all kinds of applications, but typically physical items. Right.
As well as construction too.
There you go. I'll let you answer the next question.
What's the difference between Google Earth and GIS?
Google's freeware, you can't really manipulate the data involved, so it's just kind of like what you see is what you get. With Google Maps and ArcGIS, you can actually build the different features, like the different symbols, legends, titles, descriptions.
Another one here.
There was a article that I read. I kind of did it as my WOW project, but it was talking about some company has come up with a table top kind of thing that's got latex across the top of it, and there's an imagery that will come down out of a projector, and the rods in that table somehow they match what the map is. The map that's being projected, it gets matched, and those rods will come up and show the actual elevation. And it's it's a part of the GIS that you guys are talking about, that mapping, and a lot of geology work.
Yes, it is incorporated with the computer-aided design. It is a 3D modeling which is used by the structural engineerings like this. This GIS is incorporated with this the CAD modeling, and we can visualize the things in a 3D manner.
Very good. What is the difference between GIS and GPS?
GIS is basically the underline of GPS, so you need to create the map with the data and coordinates first before you're able to use GPS to get the coordinates from the maps.
Okay.
To keep it simple, like GPS is the data in order to prepare GIS. I mean, we use it as data
Very
to
good.
prepare GIS.
Very good. Any other questions? GIS.
Satellite dependent? It's satellite dependent?
Not necessarily. I mean,
GPS without satellite.
yeah. I mean, as I said, like they are different. You can use aerial photographs, satellite imagery is a part. I mean, it's not a must. Like only satellite imagery is used. Different kinds of technology are used to get the images.
Real time or time lag?
It depends. Again, you can get both the real time and time lag. I said it depends upon the type of instrument you use. I mean, satellite imagery.
Real time, you're going to need 5 satellites minimum out of 7 to be able to pinpoint anything on that map. But if you're doing time lag, I can see something different. But I'm just wondering the application of this in not just stationary or 3-dimensional stationary movement, but in actual movement and other things related to it.
Yeah, it's not.
I was going to answer that. That was kind of what I was talking about, the real time, the limitations of real time. They simply don't have enough satellites or technology to track the movements of certain characteristics that they might be trying to map. So yeah, it's still kind of in its infancy in that sense. Most of it's used for, like I said, right now current applications are basically on object type things that don't move around a lot. I mean, of course, you can track traffic to some extent, but it's kind of in a segmented time frame.
Okay, shall we give them another round of applause?